Yeah, I think we can start. Okay. Good afternoon. So let's consider this as a customized session for you guys. Okay. Yeah. So my name is Swanan Shirsagar. I'm based out of Dallas, Texas, working with AWS ProServe, and we are presenting on Beyond the Basics, exploring PostgreSQL catalogs and extensions. Along with me, my colleague Venkat. Okay, I think now it's sounding better. Yeah. So, okay, I have a lot to present. Together we are covering a lot of ground. So, without any further delay, I'll just start, talking about this. So, Postgres catalog and extensions. It may seem a very trivial topic for few folks because it is like very basic thing, but how to use it at its optimum, and it's very important from performance optimization point of view that we all know. So we thought of covering few nuances which are, which could be very, very important for folks even though who are using PostgreSQL for a while now. So that's the intention of this topic, okay? So we are going to cover system catalogs, what they are actually, catalog views, types of catalog views, dynamic stats collection, accumulated stats views, progress reporting catalog views, and cumulative statistics system. I'll talk about that as well. Stat reset, and then some optimizing with catalog views. This is for the catalog part, okay? And you're free to stop me wherever you have questions. We will take the questions after the session as well, but if you have anything particular, let me know. And I'll breeze through some of the initial slides because, like I said, I have a lot of slides to cover. So wherever you think you want me to focus on or talk up more, so just let me know. I'll dive deep over there. Okay. So yeah, what are system catalogs? So metadata of the cluster objects like tables, indexes, data types, functions. Basically, all this metadata is stored in the system tables which belong to the system catalog. Okay. Uh, the tables are called as PG underscore tables. They are in PG catalog schema. And every Postgres cluster by default has multiple databases. Postgres database is there, and then there are user created databases. So every database will have its set of catalog tables. Okay, catalog tables, views, and functions, right? So there is a primary key on these catalog tables, which is OID, which is object identifier. It's a 32-bit integer, and that is referred, when we are actually querying and joining these catalog tables, right? So management, these tables are managed by the database engine. We don't have to basically do anything particularly to insert, update the data, unless we want to do something customized. So these tables are being managed. Okay. These are just some tips. Some catalog objects are restricted in managed cloud platforms like RDS. PG auth ID, it has password and other details. So PG auth ID is restricted in RDS. Instead, we can use PG roles view, which is created on top of PG auth ID. And also pgdumpall command, this is not a catalog table, but pgdumpall command, which is not used for dumping all the databases in RDS, that's restricted. What we can do is we can have a custom script, basically, which will back up the databases recursively for us, the same thing which pgdumpall will do. But the main use of pgdumpall I have used so far is the backing up the globals. The global details are backed up with pgdumpall-g with no role password. Okay, so that is the option which we can use still with pgdumpall in RDS. Let's look at some of the top catalog tables, top from the usage perspective, I would say most frequently referred PG database, PG table space, PG operator, PG extension. So these are like very most frequently queried, or I would say whenever we are using even a monitoring solution, most of the times the monitoring solution is hooked against these catalog tables only. So this data is being referred by the monitoring solutions also. Okay. System catalog views. We looked into the catalog tables. Views obviously are views created on top of these tables. If you query some of the catalog tables, the columns, I mean, there is a lot of data, but reading that table is kind of tricky for end users. They have, for example, PG database will have all the columns with first three letters would be DAT, DAT, DAT name, DAT ID, something like that. And for PG index, it's IND. So reading is a little tricky. So for the readability perspective, the views are created, and also we can join different tables and create view and all, and that gives us a lot of information which is very easily available. Okay. What are some of the top queried catalog views? PG stat activity. I think most of us go to PG stat activity in case of whenever we want to see what is happening in the database. So that is the first view. PG stat replication will have one row per val sender process. Okay. PG stat progress vacuum. This is one of the progress view. We can see the how much vacuum is completed and what stage the vacuum is in the scanning or scanning the index, the B tree parsing. We can see all the stages. Okay. PG stat user tables, PG stat all tables, PG stat sys tables, and same for indexes. Very, very vital information is stored in these views. Okay, PG roles and PG logs. Let's go through some of the catalog views. If you want me again to talk about anything specific, let me know. Okay. Let's take a look at PG database catalog table. It has one record per database. So initially I said, right, if you have multiple databases in your cluster, there will be system tables, I mean catalog tables and catalog views for that table. But there are some tables, catalog tables, which are above that, I would say, hierarchy. So PG database has record about each of the database. So it is at cluster level. So the question would be, the catalog tables are in the PG catalog schema for each database. So where would these tables would be situated? So basically they point to a fake database with zero ID, but yeah, and they will have information about all the databases in the cluster. Okay. Yeah, PG database has information for concurrent database connection limit, the parallel connections which are happening on the database. We can set that. We can set it. The max connection limit we can set in the configuration file, the PostgreSQL conf. But if we want to set a limit for concurrent connection per database level, we can do that over here. Okay. Frozen transaction IDs. We'll talk about that a little bit. The transaction ID wraparound situation happens if we are not managing vacuum for this. Okay. Default table space, database owner, the owner with which we have created the database. So all this information would be here. I talked about some of these columns. You can see that there is DAT prefix for all the columns, and that connection limit is the concurrent connection limit that allow connection if, let's say, you want to stop particular database accepting connections. So we can just set this data allow connection to false, and that particular database will not accept any connections. We can just block connections if that's a requirement. The frozen transaction ID will look next. So how many of you been in a situation where database is going under transaction ID wraparound? None of us. You are lucky guys. Okay, so that is like a nightmare, I would say. What happens is when vacuum runs on the database, it does two main things. It takes care of the bloated rows, the dead tuples, and the other thing what it also does, it marks the completed transaction with a dedicated frozen transaction ID. Okay, and if vacuum is not getting enough chance to execute, auto vacuum has by default least priority, auto vacuum is not tuned properly, then what happens is the transaction age keeps increasing for the relation or for the database, and there are basically 4 billion transactions which are supported, but not 0 to 4 billion, it's like minus 2 billion and plus 2 billion. So when it reaches to the 2 billion transaction ID wraparound age, the past transactions which have been happened on the database will start seeing as a future transaction, basically. So to avoid this condition, what happens, database executes vacuum freeze in very aggressive mode, and none of the other queries or requests would be served at that time, basically. So you have to basically start the database in single user mode, execute your vacuum freeze, and get rid of this situation. These are some of the queries which will help you identify what is the age of the database, okay? And once you know that the age is very high, close to 2 billion, probably 200 million is the warning level set by default in config file, and then you can execute vacuum freeze, okay? Let's say, let's talk about views which have statistical data. I said there are different types of views. So these are the first statistical data views. And before we go into that, let's see what are database statistics. Okay, there are two main types of statistics. One is the distributed stats, and others are the monitoring stats. Okay, what are distributed stats? Distribution related statistics, how the data is distributed inside the database, inside your tables, what is the basically repetition of values, what are distinct values, and this kind of distribution is basically collected by a process called analyze. So analyze collect all this data and keeps it in the PG statistic table, where I would say samples or histogram bounds are created, okay, and this information is then used by query planner to decide which plan is the most optimum plan to fetch that data. Postgres has a cost-based query planner, so these statistics are very, very important to make sure that the queries are performing at its peak, and basically they are referring to the latest and right statistics. Okay. Yeah, and the other category of statistics is the monitoring stats, which is usage metrics on the database objects. How many times a particular index is scanned, how many times a table is sequential scanned, okay? How many number of vacuums or auto vacuums or analyze have been executed on the objects, read-write times, how many times disk reads have been happened. So all this important information is being collected in the stats views, and this is done by the cumulative statistics system post-PG PostgreSQL version 15 onwards. Before Postgres version 15, it was stats collector process. I would just talk about that, the difference. What the stats collector process was doing is there was a main backend process for stats collection, okay? And every connection to database is basically a session, a fork to CPU, right? And there used to be a backend process for collecting stats from that connection, okay? So the backend process used to collect the data, it used to send to the stat collector process, and stat collector process used to write that stats information on the disk, okay? So there was a lot of disk I/O. What happened after version 15 is the cumulative stat system, instead of, there is a primary process, but instead of writing it to disk, now it writes to the shared buffers. Okay, so it writes into memory, I would say, yeah. So the I/O part is avoided, and there were some issues like stats. There were stale stats because of the I/O writing and delay, and sometimes auto vacuum didn't get to get executed because of the stats to which auto vacuum looks used to be stale stats as well. So this is the main difference between monitoring and data distribution stats. Okay. Any questions? Yeah, and one point is, obviously because these are usage stats, they would be different from primary and the replica instances, because the reader queries, the read-only queries would be executed on the reader, so that will have different stats. But obviously, these stats are same across readers and writers, because these are just data distribution stats. The data is not different between primary and replica, so we don't have to execute analyze on a replica. Okay. Yeah, dynamic stats views, accumulated stats views, we'll look into these. And we can also create custom statistics views. There are extended stats. We'll not go to that right now. Some of the dynamic statistics views are pgstat activity, which has the details of what is currently going on, which are the actively running queries, transactions on the database. We talked about that. Yeah, and some of the examples of accumulated stats catalog views is pgstat archiver, which collects basically the cumulative totals of val files which are successfully archived. Okay. There is one accumulated stats catalog view, which is pgstat slru. I don't know how many of you use that. It is not referred over here, but pgstat slru is about the simple least recently used cache. Okay. The main area where slru is referred, I would say, is if you are using sub-transactions in your workload, then the sub-transaction information is maintained in SLRU area. So whenever you create a save point in explicit transaction, backend it creates a sub-transaction, and 64 sub-transactions are recommended, or that was the limit till now. And in PostgreSQL 17, they have added, basically we can configure this limit. So that SLRU is configurable now, and how many sub transactions are happening and all that can be tracked in pgstat SLRU catalog. I should add that over here actually. Yeah.
So I just wanted to add to that. For SLRU, it's not just sub transactions.
It's not just sub transaction. Like I said, it maintains some few other functionalities as well. But the top thing which came to my mind was say the sub transactions. Of course, yeah.
There's commit timestamp, multi-transaction.
Right. MXRD. Yes. All of that. Yes. Absolutely right. Did I just missed it? Yeah. pgstat database, we talked about that. I'll just breeze through this slide. Okay, let me know if you want me to talk about this. I'll talk that. PGStat database has information about the temp files. If your sorting operation is not happening in memory, in work mem, then the files will be spilled on the disk, and that is again a big performance bottleneck. How many files are being written, have been written on particular data because of on a particular database, what's the size of the total temp bytes. This information can be seen in the PGStat database. PGStat database, actually it's not PGStat database view, it's what I meant is overview. PGStat database is, sorry, it's PGStat database, it's view only. Exact transactions committed on the database, transactions rolled back, blocks read, blocks hit. Blocks read is how many disk blocks are read, and disk blocks hit is how many blocks are basically were available in the shared buffers, and how many blocks touch in shared buffers, okay, not in the OS file system cache. Yeah, PostgreSQL only retains the cumulative or real-time statistics. It does not store historical data. So for Oracle folks, whoever is from Oracle background, that is like, how come you don't do that? How will we, generate the AWR report if we do not have historical data? So what we basically do in PostgreSQL is we take snapshots in intervals, and we maintain that snapshot in time series kind of data and query those snapshots. Okay. Catalog views. I'll just breeze through this. PGStat user table will have information about the number of live tuples and dead tuples. This is just a formula which AutoVacuum refers to before it decides whether a particular table is a candidate for AutoVacuum or not. So these are the formulas, okay? Progress reporting catalog views. These are some of the commands for which the progress reporting is enabled. Analyze, collecting the stats. Cluster. Cluster is basically it reorganizes the table based on a given one particular index, okay, and you have to maintain that. That's a cluster operation. Copy, transferring data between files and tables. In index creation, vacuum, and base backup as well. So for the with PG base backup, we can take the base backup, and that progress is also reported. For vacuum, full information is not reported in PGStat progress vacuum. The vacuum full information is maintained in the cluster table, the PGStat progress cluster, because it rewrites the entire table. Okay, PGStat reset is basically we can reset the collected stats, the monitoring stats with PG stat reset function, right? What happens is if we do that, it will, nullify all the collected stats, and the auto vacuum will not be executed in that case. Okay, so it's recommended if you have to do this PGStat reset somehow, or if your stats get reset because of faulty shutdown, you need to basically execute analyze so that the stats are collected back, and your auto vacuum will be able to cope up again. I have intentionally not given all the queries for this. You can easily get queries on Postgres wiki or check Postgres for all of this. The intention is what I have done so far, not so far, but what I used to do is just take some ready-made queries and execute them because they are very helpful. But in that case, what happens is you end up looking into certain specific catalogs only, but there is a lot of information which is available in the other catalog views, and we should take a look at that as well. These are some useful PostgreSQL blogs, and these are some of my favorite links. I hope you know these links. Otherwise, when I'll share the PPT or presentation, PGpedia, it's like Postgres Wikipedia, very, very useful. Feature matrix, which feature was introduced in what version, and all of that information. Why upgrade database? If you want to upgrade from 9.6 to, let's say, 15, what are the things you need to look for? All that information is, I don't know how, if I can, yes. Awesome. So you can just, add your source and target version, and it will give you all the changes which have happened within these versions. Okay, and observability views. This is the last thing. Yeah, so this is again very, very useful based on the PostgreSQL architecture area, which are the views which basically have information respect to that area. So very useful view. Okay, to refer to this. And yeah, that was the end. Yeah, so we'll talk about PostgreSQL extensions next. If you have any questions, let me know. I can talk about that. Okay, thank you.
Alrighty. Just want to quickly switch here. All right. So we're quite a rapt crowd here. So let's kind of run through this. How many of you are aware of extensions in Postgres? Have you ever used some of those? Most of the time you do, right? So what I'm going to talk about today is pretty much a recap of what you might already used. Maybe give a couple of new extensions which you have not tried. But it's some of those. These extensions are like a lot of them out there. And you probably will use things which you need. Most of the time, you don't have things, but it's good to know what's out there. Before I get started, my name is Venkat Govindarajan. I'm the database solutions architect, a specialist with AWS, and I help my customers with different managed database services. And one of them is RDS Postgres, and second one is Aurora Postgres. So I'm excited to kind of share with you some of those experiences which I have. So today's thing is working? Okay. All right. My clicker is not working, so that's good. All right. So today we're going to talk about a bunch of these things. I think the battery is out for this thing. Yep, battery is done. So a bunch of extension categories. We talked about performance, admin, some sources, replication. I'm not going to try the thing. The performance and admin was covered by my colleagues in the previous section who attended that section with Rajiv and Anita, right? Okay, good. If anybody didn't attend it, I'm not going to go through it, so you missed it. So, right, that's how it is. So I'm going to jump right into the next one, which is data sources. Right, and with data sources, we have a bunch of FDWs. How many of you have used FDWs? Foreign data wrappers. So foreign data wrappers is nothing but like extensions to help you with, for in this case, connecting to MySQL or Oracle or this thing, or even going to the log and FDW, things like that. How does that happen? It's typically like you have a select data and you can have a foreign table sitting in Postgres, and that foreign table is actually not in Postgres, it's some of the other databases, right? And it can be another Postgres, but it also have MySQL or SQL Server or Sybase. And typically how we do it is very simple, right? You create a server, create the link, you grant the users, you map this user, then you create the foreign table in the current and import the schema from that. So that way you are ready. You can start querying, and as you might feel that you are actually the data is sitting in your database. In fact, I have a blog down here, and this is about one of my customer use cases actually, where we were able to migrate from RDS SQL Server to Aurora Postgres using FDW. Right, because they had issues with DMS and other migration aspects, but we were able to do it, and this whole thing was done in 2 hours. So we're sitting in customer location, and we didn't know what to do, and this was done in 2 hours. The customer was in Bangkok, by the way. So just added notice for you. So, and don't smile, man. Come on. Anyway, I went there for work. So. All right, so that's FDWs for you. And the next one I'm going to talk about is replication, is PG active, PG logical, vol to JSON, and text decoding. Basically, PG active is active database replication, right? Like, if you want to have both multi cluster writes, PG active is a source for you. PG active has mechanisms to kind of to resolve the conflict resolutions, resolve the conflicts, and the way it does it is the latest one wins. So be extremely careful while using that, because if you're actually using some transactions, right, and which can potentially override each other, then you might have a situation where you might miss data. So there are certain strategies to do that. So don't make sure you have a clear path of how you want to manage your thing. That's with PG active. That's the next slide, I think. Yeah, and see, this is how you want to set up the active setup. You can do that. You can set up all this extensions out there. As I said, I'm just running through this because I have tons of extensions to cover. So I just want to, if you have any questions, you can always come and ask me later. The next one is PG Logical. How many of you use PG Logical? Have you guys used PG Logical? Okay, PG Logical is a true logical replication, right? We use it extensively, right? As part of our migration path, one of the migration path from Aurora into Aurora, or from Aurora to another data RDS, or from regular Postgres, we typically use PG Logical. PG Logical is a logical, replication data, right? Basically looking through the wall logs and go from there. Yeah. It's a good question. Just to start with, PG Logical supports database replication, the data replication, because it looks at the logs, wall log. So if you have to do that, you have to create the schema beforehand to do that. Yeah, because because the DDLs are not logged transaction. It does that, but not all of them are basically are log transaction. It does to a certain extent, but best practices is always create a DDL first. Even DMS, I don't know if you're familiar with DMS, it's a database, it does that too, but our best practices say that, hey, create the DDLs first. It becomes easier for all of us to go for. See, PG active is a little different in the sense that it does use logical replication, but in PG logical, what happens is it's source and target, right? In PG active, it's source and source. You can write here, you can write here, right? So that's a key distinction between that. Even though it does all the mechanism the same, and then basically what PG active does is captures the timestamp on each and every transaction. And basically, that's how it basically says, hey, you know what, this is a later transaction, let me hold this and delete the other one, or remove the other one. So that is the challenge you will have with conflict resolution. I don't know why they call it conflict resolution. Actually, it's not a conflict resolution. You're just discarding something which is old, right? So that's what it is. So that's the key difference between that. PG logical, you can write only one side. The other one is read only for you. Text decoding. So if you want to write something if you want to read something from the wall logs, right? This is one of the things to do that. You can also do the JSON representation of what the wall log data is. So you can use some of those things as well. AI machine learning. Who has heard about AI now? Anybody? Right? I said somebody, if somebody gives me a penny for everybody says AI, I'd probably be a multi-billionaire by this time. because it's a loosely dropped term, but like, it has built a lot of excitement in the market, and it has also built excitement in some of those legacy database systems, right? Like not relational database system, I won't say legacy relational database systems. So we have two things, Postgres PG Vector and Postgres ML, right? So have you heard about PG Vector before? Have you guys used it? Right? So, I'm just going to quickly run through this. Like, it's basically a type of storage, right? It's embeddings, converting a particular image or kind of an content into an embeddings, into a mathematical way it is to store the data. And you can quickly search through this in multiple index formats. You have like IVF flats, and you have HNSW. And you can use algorithms like nearest neighbor, and approximately, and to find out like what is the closest match. So you can have an image, you have a dog, and you have a bunch of dogs. You can basically, and humans, you can basically run some algorithm and say, hey, give me all the pictures which have dogs in it, right? So some of those things. Metadata as well, right? You can have like, you can co-locate the embeddings and making sure that like, all the images are co-located such a way that you're able to quickly search things. And finally, like, you can have distance operator, like give me greater than, less than, things like that. So these are some of the things happening using PG Vector, sorry. The key factor is basically how you're storing the data and where you're storing the data, right? So, I got to tell you this anecdote today. I was working with Swanan the other day, like, and I was trying to register for PG conference. That image, click on that thing. It pissed me off, man. It went for like how long? It kept on doing it. I had to do it for 10 minutes, and then I said, screw it, I'm not going to do it. Then when I went back and do it, I was able to do it. So they probably should have a better vector embeddings to make sure that at least they recognize the image properly. So it was a side note for me, not it's nothing to do with this presentation, but that was my pet peeve and my grievance, which I kind of shared with you guys right now. Yeah. So generally, embeddings are generated by an ML module, right? So I don't know. PG Vector itself is pretty recent ones, right? It has been there for a while, but now it become prominent. But generally, the embeddings are created by a AI ML model. I don't. You can do that. You can do that as part of a lambda function, because in Aurora Postgres or even RDS Postgres, you can invoke a lambda function within a store procedure, right? So you can hack it to run like that, but we don't have an extension which does that for you, right? And I don't think you don't want to run anything ML within the Postgres database. Then you're sucking up the resources. They want to put it there. They want to put LLMs or SLMs. Okay, SLMs is different. SLM is fine. LLMs are like huge. So like yeah, as I said, like a penny for something. Somebody says LLM AI, generative AI, like it's going to go a long way, man. So okay. Geospatials, geospatial PostGIS and BG routing. PostGIS is basically very common, very common. Have you guys used it? So PostGIS is nothing but like taking a location and converting into a tabular format. So think about it, right? Like you have immediately you will say, hey, it's longitude and latitude. It is columnar. It is not actually, because like tell me one thing, like if I have to get a taxi in New York City, I'm standing in the middle of Times Square, right? If I'm storing the data, how do I know which is the closest taxi, right? It is not that easy to do that in columnar stuff, right? So even though it is a columnar means like rows and tables. With this, you're able to kind of quickly identify it and run some of those queries, right? So radius, distancing, and all those things are seemingly easy tasks from our point of view, but from the database point of view, it's a big thing to do. In fact, like I had a similar project done on another service of ours called Elastic Cache, which has got a similar kind of pieces of processing, and with a single command, we basically can have the entire process, like find out what the number of taxis near me in a particular location. So that's PostGIS, basically like getting it to a point where you can have all the data stored, the geospatial data stored, and also query on it and search on it. The second one is PG routing. PG routing, as routing says, like, hey, it tells you what is the closest route. Give me a point between point A and B. You have 2 routes or 3 routes. Tell me what the fastest route is. Tell me all the route which does not have tolls. So those kind of statistics can be kind of found out from this extension. Monitoring and logging, process tab, and audit. How many of you use PG audit? Right? Right? It just checks the process. Right? This is PG audit. Okay. So PG audit basically captures the details of a record. What else? How are you doing? What are you doing? Who's doing what? Right? Venkat comes and drops a table in purpose, or deletes data in purpose. That something is captured here, and you can go back and basically track all those things. You can track who is reading what. Right? So some of those things. Okay. Quick quiz for you guys. I'm coming to a table and I'm searching for a data set which I don't have access for. Will PG audit catch it? It will not. Because it will raise an error, and the error is captured in the error log. Right? So just food for thought. Right? PG proc tab, like basically process tabs. It checks about all the keeps track of all the processes, like what all the process ID, what it does, and CPU statistics, all those things for that particular process, right? So it is good for posterity as well, like what happened later as well. So it talks about what query came in, what kind of utilization it had, what kind of OS resources it took, what kind of speed power, compute power it had. So it's all good stuff for you guys as well to go forward. How do you manage extensions? So how do you manage extensions, right? So you can check extensions by setting a table, PG available extensions. You can install extensions by creating extensions. List of all the extensions is there, of course, there in PG extensions, which you already updated. You can update an extension with the latest version. We can talk about that as we can do that. And you want to have list of specific extension versions. So you can have multiple versions, multiple extensions with a similar different versions on some of those things. These are some of the call to action, like PG Partman, I think Partman, Anita spoke about it, PG Cron Chief spoke about it, Repax spoke about it, Vector we spoke about it. There's something which you wanted to look at. PG Hint plan, I think Rajiv spoke about it. I didn't talk about hyper PG. It's too much of heavy lift for this session. But if you have any questions, you can definitely come and ask me.
Hyper PG is nothing but you can create hypothetical indexes. If you have a question like there is particular table, if I create index on particular column, will that be beneficial or not? So the hyper PG architecture is basically it passes to the queries which are getting executed. It creates a hypothetical index, and if before and after plan has difference, before plan has high cost and after creating the index has lower cost, then it suggests that creating index is beneficial.
Yeah. So you can use that, or what you can do is create a clone in Aurora, create an index, run it, and create the same thing, right? So that's there are many ways to skin a cat. What is the easiest way to do it, right? So that's some of the things which we like to do. And I think I'm done. So with that, I'm done with Venkat Govindajan. That's me. That's my LinkedIn. I'm done. So Swanand is there, and yeah, thank you for staying and telling that. Can take a picture of me. At least you can put it in the thing, so that hey, you know what? I also gave you extra 5 minutes. Now you can go grab food, okay? Because here we gotta do it, right? So it's simple as that. Oh, thank you. Thank you. Okay, yeah, take it that way. That is easier. Yeah, have some kind of an as if you're talking. Thank you. Okay, thank you. Appreciate it. Yeah. So it depends on that, because a lot of times when you increase when you do an upgrade, right? So when you do an upgrade, you basically like extensions may or may not work.
Yeah.
So you have to update the extensions which don't work. Some of them, like for example, PG Partment, they generally work.
Yeah.
Right, so nothing, right? But there's something like, for example, PG Vector, the embeddings might have changed, the way they optimize it, right? Those can change. Once if that happens, that's why you can have multiple versions of it, right? So that like, you want to choose the best version, what works for you, right?
But it's a good practice to check whatever extensions you are using in your source
Yeah.
version. Check